Well, good morning and welcome to our first presentation at Cosmetic Business. We are happy that we get to be the first speakers this morning, and we will talk about eternity colors today. So I need the presentation on the screen, please. I don't know who's in charge of that. Okay, thank you. So first of all, I'd like to present myself. My name is Jessica Knoch. I'm head of marketing at Lifocolor. And by my side, my esteemed colleague, Andrea Hanke, who has been head of the technical and colorist area for many years. So in the next 25 minutes, we will show you this green thread through our presentation. We will talk very briefly about us as a company, so who's in front of you and in the background. We'll be talking a bit about our concept of eternity colors, what are the thoughts and the vision, the philosophy behind it, master batches for sustainable polymer coloring. In Ms. Hanke's part of the presentation, we will talk a bit more about the actual product solutions, innovations, which we have for the circular economy of biopolymers on the one hand, and on the other hand for the mechanical circular economy for recyclates or polymers who enter into a cycle for the first time. And if there's still time, we'll have a short wrap-up and the option for you to ask questions. So our business card. We are a master batch producer with our main headquarters in Franconia. We produce color master batches, but also combined with additives or pure additive batches for the coloring, stabilization and functionalization of plastics, of polymers. We can also offer compounds, so that means a completely colored polymer that can be further processed. We have roughly 300 employees in 5 sites in 4 countries, 2 in Germany, 1 in Czech Republic, and 1 in France. We produce up to 10,000 metric tons of these little packages of power that you can see here. So colors, pigments, everything bundled together on polymer. And for our color concentrates, the master batches. Now our concept of eternity colors. Let me talk a bit about this guiding principle. So color has fascinated us for many, many years, 40,000 years to be precise, based on the hitherto oldest discovered cave painting that has been discovered in Spain. And back then, the colorants were taken from nature. Where else? So plants, minerals, whatever was at hand back then has served as a colorant for painting. And this close connection between color and polymer has been in existence ever since polymers came into existence, because people thought about how can we give the products an aesthetic value, so meet the aesthetic needs of customers, communicate an image, inspire emotion, but also protect the fillers or provide an orientation spot through color in the polymers themselves. And this goes well beyond the cosmetics industry, of course, or marketing. So as a producer of master batches, of course, we want to make sure to keep this color in the cycle, in the circular economy. What does that mean for us? So we're moving in a field of tension here. So we have the EU Green Deal on the one hand. So there's efforts for mechanical circular economy, circular quotes, etc. These are all keywords or buzzwords. But the question is, what should the color look like when polymers are supposed to take several turns in the cycle. And so we have to think about choosing a colorant at an early stage. So the color must be made in such a way that it can go through the usage and the recycling phase and supports that ideally and does not hinder it in any way. Ms. Hanke will talk more about that, of course. Now, for the biomass cycle, it is a completely different kettle of fish, particularly when we think about the cycle being originating in nature and ending in nature. When we talk about home compostability and other natural breaking down processes in nature. So we're at the top level here, and we have to find out how natural do the colorants have to be, and how can they be processed in a way that fits everybody's needs. And the third field of tangent, in the EU, there are more and more restrictions in place. For example, if you know a bit about the polymer business, BFAS right now, pre-polymers have been under fire. Maybe you've heard about titanium dioxide, widely used white pigment. So everything's being put to the test, and this poses challenges for us. So what can we do about our master batches? What ingredients can we use to make our master batches more humane, more environmentally friendly? This is the third component which concerns us and takes us to this idea of eternity colors, which is which colors and under which conditions can these colors continue to be produced? What angle do we have to take when looking at them? So on the one hand, we can see it in this beautiful image here. Nature is giving us so much colorants, but also just impressions of color. So on the one hand, we want to check how can nature continue to inspire us, and how can we conserve it? How can we preserve these gifts? How can we translate that into color? How sustainable do the color have to be? These are all things that play into that. But also, what colorants can we use in order to delve into these eternity colors? And it's not about colors being eternally present in that cycle. It's not possible, at least not in mechanical circular economy. But how can we make this connection between color and polymer eternal? That's the idea behind it. And of course, that plays into the evaluations, the professional assessments. So we have to stay curious. We have to reassess constantly how we do that. Now I'd like to pass the floor to my colleague, Ms. Hanke, who is going to talk about this from a bit of more technical angle. Thank you, Jessica, and good morning from me too. So let's talk about our eternity color and innovations for biopolymers. As you know, there's different types of biopolymers. Not every biopolymer is made from renewable resources. They can be, or partly. We call these bio-based polymers. They can also be degradable, but don't have to be. Even biopolymers from mineral or fossil resources can be degradable. Depending on the type and the individual requirements, we choose a virgin material that matches the client's requirement. So for you to better understand that, for our standard master batches, we use fossil standard polymers and stable, high-quality colorants, as we do with all our eternity colors. For bio-based master batches, we use 100% bio-based virgin material in order to have the finished product consisting out of organic material, bio-based material, including all colorants. And depending on the polymer to be colored, we use bio-based master batches when the finished product must be compliant with the EN 12432 standard for compostability. And there's when we need requirements for home compostable application, and the carrier, the virgin material and the colorants must be adapted to that. That is the fourth category. So the selection of our colorants is made based on the criteria of their chemical composition. So all colorants should break down into water, carbon dioxide, and bio-friendly organic molecules or minerals. This is eco-friendly, and there is no toxic substances or contaminants being released into nature. We also make sure that our master batches make sure that the stability and functionality of the finished products or products to be finished is not affected in any way during the process. So in the course of our Eternity Color concept, we developed a new level of master batches based on 100% natural and partly even vegan colorants. They are produced in very gentle processes in Europe. These master batches have a very broad selection of color. You can see a few examples on the slide. They are processed at a temperature of 240 degrees in extrusion and injection molding process. So these colorants or these color products are ideal for bio-based and biodegradable polymers, but basically they can be used with any kind of polymer, as long as the temperature of 240 degrees is not exceeded. So, of course, we would also like to point out a few challenges in that area, because the picture that you see here does not show samples from a spice cabinet, but various bio-based and biodegradable biopolymers. And these biopolymers have different requirements for coloring due to their own intrinsic color. So the darker and more opaque the raw material is, the higher the challenge to have a certain color spectrum achieved in the right intensity and color fastness. So this may require higher doses and associated with us higher costs. Let's now talk about a few solutions for the mechanical circular economy. So our recyclable master batches are usually mainly polyesters and polyolefins and other polymers too, but polyesters and polyolefins are the main materials, the principal materials. So they are available on the basis of PCR material or virgin material. So in order to achieve the intended color according to the client's wishes, we make sure that the colors have high color fastness and they are stable, they have a good migration stability and color stability. Our master batches go through a number of extrusion runs and can withstand that. As you can see in the example in blue, after 10 extrusion runs, the color is still as color fast as it was in the first run. We have sorting systems working in the near infrared range and separate by color and polymer type. With NIR scanners, you can quickly detect polymers. So if the colorants absorb NIR, that makes it more difficult. This becomes particularly evident with polymers containing soot, because they absorb the radiation instead of reflecting it. So therefore, polymers that are black or colored with soot, so products containing soot, cannot receive a signal that is sufficient. and consequently, they cannot be sorted and not differentiated by polymer type. And that is a challenge for the recovery and recycling companies. So Lifocolor NIR detectable master batches guarantee the sorting. That way, the master batches by Lifocolor can be detected even if they contain black, they are correctly sorted, and they can remain within the cycle, the recycling cycle. When coloring recyclates, we face a number of similar challenges to biopolymers. Regarding the intrinsic color of the virgin material. So in the image you can see a couple of different PCR types and qualities. You can also see the color quality, because by now the sorting plants cannot just differentiate by polymer but also by color. And that is possible because each color has a different wavelength. And that leads to a plethora of PCR materials which must then be converted into a color highlight. Now in these shades of gray here, the principal results when coloring PCR materials are like that. So you can see they are colored all the way through. They're opaque. You cannot take anything out. I have to work with what I have, whatever this offers me. So all I can do is color over this. So I cannot achieve any transparent or translucent results. Well, so much for the barriers and hurdles. So this may have sounded a bit pessimistic with all these problems and challenges, but let's also have a look at the opportunities, because there are ample. Time and time again, we take recycled components for our Eternity colors and we use them in our Trend Colors projects. And we always achieve very good results for those. This year, too, we have a few cooperation projects with our Trend Colors. And at our booth E02 in Hall 4, you can see those. So if you would like to know more about this mountain of information from this presentation, please come and visit us, or if you have any questions, or if you would like to check out the new Polymer Trend Colors 2024. Oh, great.
Versucht das Ganze noch, weil wir ganz gut, genau,
we are doing pretty well for time, so just a quick wrap-up. After our business card, we talked a bit about the concept of Eternity colors, about our approach, how we sustainably design master batches. We looked at this in the context of bio-based polymers, biopolymers, where we are very close to natural colorants, and this is working out pretty well. We can process them, and a lot of research and development work is going into that. And this cycle is almost closed, which is a pretty good example. And in the mechanical circular economy, we looked at the innovations, what works, what doesn't work, a few challenges and problems. But we can also say that with our color solutions, we are heading in the right direction. And we are confident that we will achieve our goal. So if you have any question in the audience, any questions that we can answer right now on the spot, now is the time to ask it. If not, we'd like to thank you for your attention. We wish you a pleasant stay. And come see us at booth E02 in Hall 4. We'll be there all day. Thank you very much for listening.